Okay, so you know it's always going to be a good lesson when the title takes up half of the first page. Thank you very much. We're going to look at exponential, log, equations, and the change of base formula. So why are we doing all this log stuff? What good is it in terms of solving equations? So we started off with the idea the other day of saying, well, we can't solve 3 to the power of x equals 10. Right now, we haven't really got a method or strategy of going about that. Also of note today, something like log base 2 of 5 equals x. We need to get a method to solve that as well. So my exponential equation here, my log equation here, how can I solve both of these? So what I'm going to do, I'm going to do a little bit of rearranging here. You need to note that your calculator will be necessary for both of these questions, and for both of these questions you're going to, on the calculator is, I mean, as good as it is, it can't do a bunch of logs. It can't do log base 2, it doesn't know how to do log base 2. Okay, if you get a fancy calculator, yeah, it can do log base 2, but the standard one you're allowed in your HSC will not allow you to do log base 2. You'll be able to do 2 logs. You'll be able to do the natural log, so log base e. Also, so log base e can be rewritten as ln. So you get this bunch here, and you also get log base 10. And log base 10 appears on the calculator as just general log. If you see just log, you can assume in most cases that it is log base 10. Alright, calculator can only use one of these two, so we need to do a little bit of rearranging here on the algebra. What I can do, it's perfectly legitimate to take the log of both sides of an equation. So I'm going to come along to this equation here, my exponential, take the log of both sides, and take the natural log ln. So logging both sides here, just a little bit of algebra work. From my log laws from last lesson, if I've got a power here, the power can come out the front. So this equation here is the same as x log 3 equals log of 10. Natural log of 10. So log 3 is a number, just like sine 6 is a number. So I can divide both sides by log 3. Divide that by log 3 as well. Log 3 will cancel. So I've then got x is log 10 divided by log 3. Going to leave that in exact form, mostly because I don't know what my calculator is. Okay, so it should be, it should be 2 point something. They'll tell you exactly what it is. Put that in your calculator. Make sure it goes in the calculator as it appears here. Otherwise, you're going to get yourself in a bunch of trouble. So that's solving an exponential equation. So you can log both sides. Log that, log that. As I said last time, logs, exponentials will undo each other. Okay, so you can expect a little bit of undoing in here. This is a little bit more difficult, so how do we solve this log equation here given it's log base 2? Our calculator can't do log base 2. So here, what most students would reach for would be a change of base formula. Okay, and if you want to change a base, that will be fine as well. Alternatives to change a base formula you have is to rearrange. So you should know from last lesson, hopefully you recall this rearrange, so version 1 of doing this. Rearranging it's going to be the same as 2 to the power of x equals 5. And we can then solve that basically the same as this question here. Okay, so there's one way of doing it. I don't mind rearranging it. I generally prefer to rearrange it. If you do like to change a base formula, that will work for you as well. I'm going to finish the rearranging version of it, and then from there I'll show you the change of base formula, take you out of your misery not knowing. The change of base formula, to note, is on your formula sheet, so don't freak out about memorizing it. Anyway, continuing on with this thing here, if I take the log of both sides, I'm going to take log base 10. So if I come along, log 10, I will then get, I'll pull the x out the front as well. So I'll get x log 10 of 2 equals log base 10 of 5. So again, I'll divide both sides by log base 10 of 2 divided by log 10 of 2. That's going to leave me with x, because they cancel, equals log 10 of 5 on log 10 of 2. Like I said, I generally prefer that method. Okay. There is a change of base formula though, so second alternative method of doing it. And it says, this is what your change of base formula says, it is a rule, you can use it, it's on the formula sheet. It says that log base a of x is equal to log base b of x on log base b of a. That is a rule. It's a formula. You can derive it. We've basically just done the derivation with an example. So what we're saying, if we have log base 2 of 5, log base 2 of 5, log base 2 is on the bottom, log base 5 is on the top. I've introduced, there's no log base 10 in my question here, there's no log base b in this side here, I've introduced log base 10 here. So log base 10 came into it because my calculator can do log base 10. So from there, simplifying, working down, it's the same form you'll see. It's 5, 2, xa, xa, 5, 2. So there's consistency there just in terms of the lettering. The change of base formula, if you have this question here, you would be able to say, well, it's going to get confusing with the x's everywhere, but you would be able to say that just taking that side there, you can say that log 2 of 5 equals log base 10 of, and it's going to be 5 on log base 10 of 2. Okay, it's a little bit arbitrary just going from the formula, I think, to the new bases. That's why, like I said, I prefer method 1, but yeah, either one will generally do. Let's grab some more examples because I think it's necessary we do get a little bit of practice. Okay, so we've got two good examples already. They're both pretty good. Going down. So let's go and evaluate. Let's clear that screen altogether. Let's say log, no, let's not even do that. Let's say that 4 to the power of x plus 5 equals 15. Okay, so right now there's no obvious thing coming out in terms of our powers here. So we could log both sides. I would go for that. Logging both sides is perfectly fine. Natural log, because it uses e. E was helpful with exponentials. It's also just easier to write. There's less writing than log base 10. Anyway, power comes out the front, so this is the same as x plus 5 log 4 equals log 15. So dividing both sides by log 4, natural log of 4, that will cancel. So x plus 5 equals log 15, natural log of 15, over natural log of 4. Note that there's no log law that cancels these. Don't get confused in your log laws. Okay, so x is going to be just log 15 on log 4 minus 5. We'll grab another log question, just a little evaluating of a log. Let's say, I'll try and find a good one. If we had 2 log, oh, don't want that log, other log, give me a second, 2 log base 8 of 9, and let's just go and evaluate that. So we'll set it equals to x. So right now, if you are a fan of the change of base formula, you're going to have a bit of a hard time. What are you going to do with this 2 at the front? So if you write it this way, 2 log base 8 of 9, and what you could do, you could come along and put the 2 at the front, say here-ish. That would work as well. If there was 2's there and 2 there, that would be fine. I'm going to do it my way because I like my way best. I'll do the change of base formula as well for you, just to keep you guys happy. So dividing by 2, I get x on 2 equals log base 8 of 9, or 8 to the power of x on 2 equals 9. X on 2 log 8 equals log 9. So x on 2 is log 9. I used the wrong log again, didn't I? No, I'm right. I'm good. Sorry. I have converted to the natural log. I've taken the natural log of both sides here. Natural log of both sides, because my calculator can do the natural log. Finishing off here, log 8. So x is 2 log 9 on log 8. Doing it by change of base formula. So change of base formula, if I am evaluating, I can say that x equals 2, and it's going to be log 9 on log 8. Okay. The reason I don't like to change the base formula is people get confused what's on top, what's on the bottom. Remember what's on top here is on top here. You're fine, but I'd say just be vigilant. If you do it that way, just straight to the calculator, that will get you the answer. Obviously this is shorter, but I think there is actually more room for error by the time you memorize the formula wrong, by the time you substitute into the formula incorrectly as well. This is showing a little bit of skill in your logs, also help you refine your skills for later on. So when we do some integration questions, exponential, some log questions, you'll want the skills, so it is worth pushing through there a little bit, deriving formulas there. I think that's it for now. I will leave you to it. If you've got any questions or anything, please let me know. Thanks for watching, guys.